Okay, let's talk. We're not going to do so much with the first part of lesson 55, dealing with the advanced abstract equations. Again, when we're talking abstract equations, so, oh boy. At the very beginning of lesson 55, they're talking about, that looks like an S. They're talking about abstract equations. So I'm hoping that we all are understanding what an equation is, right? That's when you have an expression equaling an expression, right? So whenever you have that equal sign, you're dealing with an equation. Abstract means you only have variables. Most of the time, because math textbooks are mean, cruel, a lot of these will be fractions, but you have to use the same rules as if you were dealing with numbers. You'd have to have common denominators. You have to use the rules for solving an equation. Did you pick up the Barbie mess? So if I were to give, let's just go through one now that I've started explaining it. Let's just go through one. So if I have a over x plus y over m, and then equals c, okay? Well, they are saying they want us to solve the equation. Well, what in the world do they want us to solve the equation for? They'll tell you what variable they want you to isolate. Okay, so, you know, because you have 1, 2, 3, 4, 5 different variables in here, I don't know the value of a single one of them. I don't really care. What they're saying, though, is to solve for x. Okay, so what they want, what they're asking me to do is to get x by itself and every other variable over there. Okay, so I'm going to have x on one side and the 4 other variables written as some type of expression over here. Well, what I have to do first is look at here. You have fractions, right? So with rules of fractions, when you're adding fractions, you got to have a common denominator. And my common denominator for this fraction is going to be xm, right? So I'm going to multiply every single term by xm. And then when I go through here, these x's are going to cancel and these m's are going to cancel. So my new expression, I have like a glare I can't see, is I'm going to have am plus xy equals cxm. Notice how when I multiplied every single term by my common denominator, I've eliminated the fraction, right? So the x is canceled. So now I'm just dealing with a linear thing. I no longer have this rational mess. So now it's going to be easier for me to get my x's by itself. Except for the fact that I have 2 of them, right? So here's an x and here's an x, and they are on opposite sides of the equation. So that's a problem for me because I need one x by itself and everything else on the other side. So what I'm going to do is I'm going to get this x term, to the opposite side, and hopefully I can do that before I have to kill Peyton. So I'm going to get this am equals cxm, and I'm going to minus this xy term to move it to the opposite side. So I'm going to use my inverse operations, right? So then I'll have minus x. Oh, that's not even the same color. And I'll have minus, I did it again. What is my problem? Okay, so now my x terms are on the same side, so it's going to be a little bit easier for me to isolate them. So when you see this, you have cxm minus xy, and what I want you to visualize is, let me do a little side teaching over here. So let's pretend that we have 4x squared minus 4, okay? And when you see something like this, your brain realizes that you can factor, No, you don't. No, you don't. You take your paintbrush and you wipe it on the paper towel. I didn't care. Nope. Your brain sees because we've been practicing factoring stuff like this since, I want to say, pre-algebra, 8th grade, right? You can take the 4 out of both of those, right? And what you would be left with is x squared minus 1, right? I can do the same thing here. I can factor that x out because it's in both terms. So then what I would have is cm minus y. Right, so I factored, they both share the x, and I can factor it out because this hot mess right here is being multiplied at c times x times m minus x times y. So I can factor that x out, and then I'm just left with the cm in my first term minus that y term. So now to get x by itself, it's so much easier because I have 1, and I can just divide both sides by that the quantity of cm minus y. Keep it in parentheses because it is a quantity. It comes together. It's like a group package. So then I'm going to erase this because I need a little bit more working space. This is going to cancel here. Look at that. My x is all by itself, right? So I'm going to have am over the quantity of cm minus y equals x. And because of the reflexive property, not the reflexive property, the symmetric property, I can flip this over, right? And I can just say that x equals am over the quantity of cm minus y. So those are abstract equations, and I'm sure now I should probably pause and make a new one. So there's the first part of lesson 55. So if you see problems like this in your cumulative tasks, this is how you're going to solve for one variable.